Windows 10 architecture. Here we are considering the convergence journey under Windows 10 architecture. In 2015, Microsoft released Windows 10, which came with Cortana, a digital personal assistant like Apple's Siri, and the web browser Microsoft Edge, which replaced Internet Explorer. Now we are focusing on Xbox 360. In 2005, the Xbox was replaced by Microsoft's Xbox 360, but even with the superior console available, many players continued to use the original Xbox and take advantage of the Xbox Live network. Hardware modification and software piracy remained an issue with the Xbox 360, but Microsoft took the dramatic step of banning 1 million accounts from the Xbox Live network in 2009 when it detected that those users had circumvented the company's digital rights management protections. In an intensely competitive market where the Xbox 360 faced strong pressure from the Nintendo WII and the Sony PlayStation, Microsoft struggled to make consistent profit from its console. For example, in 2009, Microsoft cut the price of the Xbox 360 Elite by as much as 25% in order to pick up the market share. The move was successful. By 2010, the Xbox 360 was the most used game console in the American home, and the Xbox Live network boasted more than 20 million subscribers. Here you can see Xbox 360 architecture. The Xbox GPU consists of two main parts, which are GPU core and EDRAM die. The GPU communicates with the Xbox CPU through its BIU bus interface unit, which is directly connected to the CPU's FSB front side bus. The BIU is also connected to the main memory through the two GDDR3 memory controllers, while the IO unit connects to it to the south bridge. According to Microsoft, this configuration cut down the latency when CPU needs to access large chunks of main memory. The GPU core also communicates with the main memory and the I/O circuit southern bridge chip through another unit called memory hub, which is directly connected to the main memory controllers. The display controller is also fed with the buffered frame through the memory hub unit. Notice that the Xbox uses an external outside the GPU DAC chip for video conversion. The two GDDR3 memory controllers 2 multiplied by 64 bit are connected to the main memory 512 MB memory. Each controller communicates with 256 MB GDDR3 memory kits at a maximum speed of 22.4 gigabits per second. In the EDRAM, the EDRAM die unit is manufactured by NEC 90 nanometer process and consists of an array of 192 processors responsible for pixel processing such as anti-aliasing, AA and alpha 4/Z processing, etc. Microsoft has added 10 MB EDRAM memory unit for rendering inside the EDRAM die directly connected to the rendering unit 256 GB per second. In order to avoid utilizing resources from the main memory. The EDRAM die unit is contained in the GPU unit. The CPU. The Xbox 360 is equipped with a huge 3-core CPU running at 3.2 gigahertz. Uh, 1 MB L2 cache is shared among all three CPU cores, and the communication with GPU is achieved through 21.6 GB per second FSB front side bus channel. The South Bridge connection through PCI Express. The GPU is connected to the South Bridge chipset I/O controlling unit through a dual PCI Express interface. 10 GB per second. The Southbridge chipset also include XMA decoder for audio, reducing the load on the CPU. The external I/O interfaces includes SATA 20 GB hard drive, 12x DL DVD recorder, USB memory unit ports, MU, Ethernet controllers, etc. The provided I/O interfaces look similar to those that will be found in Sony PlayStation 3. The GPU and CPU transistors. The GPU core unit uses 232 million transistors, while the EDRAM die, the pixel processing unit, uses 100 million transistors. The 232 million transistors on GPU unit is about 40% more than those found on ATI's Radeon X800 R424/423 GPU, and is almost equal to NVIDIA's GeForce 6800 NV40 system, 222 million. However, considering that Microsoft's early announcement for the Xbox concerning 48 unified shaders, 232 million transistors seems small. This might mean that ATI has possibly used some new techniques in the unified shader design. For comparison reasons, the GeForce 7800 GTX G70 from NVIDIA uses 302 million transistors for 32 shaders. The RSX variety synthesizer GPU installed in the PlayStation 3 has a comparison similar to the G70. In addition, Microsoft disclosed the number of transistors of the Xbox 360 CPU. The CPU unit uses 165 million transistors, a number equal to that found in Pentium 4 6XX Prescott 2 million CPU, Prescott 2M CPU. On the other hand, IBM cell processor on PlayStation 3 uses 241 million transistors, which is roughly 1.45 more than those found in found on Xbox. Here in this diagram you can see the CPU 3.2 gigahertz. You can see the CPU core 0, CPU core 1, CPU core 2 power PC, and within CPU core you can here VMX, and you can see FPU, and L1 data and L1 instruction. These these three CPU cores interacting with 1 MB shared L2 cache, and 1 MB shared L2 cache interacts with FSB front side bus. Front side bus interacts with IBU bus interface unit in GPU main die in GPU. Here its connection from FSB front bus to IBU bus interface unit is 5.4 Gbps per pin, and 10.8 GB per second W. Here IBU bus interface unit to FSB front side bus, the connection is FSB 21.6 GB per second and 10.8 GB per second R. Here you can see a GPU main die plus EDRAM die. You can see GPU main die, and here you can see EDRAM die. IBU bus interface unit interacts with GPU core 500 megahertz, and GPU core interacts with memory hub. The memory hub interacts with memory controller 0 GDDR3 64-bit and memory controller 1 GDDR3 64-bit, and IO and GPU core 500 MB 500 megahertz and display controller. The memory controller 0 GDDR3 64-bit is interacts with GDDR3 512 MB X16 here, and here and in the main memory of 512 this communication is 22.4 GB per second. RNW, read and write. And memory controller 1 GDR3 64-bit is interacting with again GDDR3 512 MB X16, and this connection also same. This connection is here. This connection is 128 bit and 1.4 Gbps per pin here, the main memory, and this is the main memory of 512, and this is shared memory of 512 MB. Here the display controller is connected to analog chip, and it is passing video out. Here in I/O is I/O interacts with PCI Express. PCI Express interacts with PCI Express in Southbridge. From PCI Express in Southbridge to PCI Express in GPU, the communication is 500 MB per second, right? And from PCI Express in GPU to PCI Express in Southbridge, the communication is 500 MB per second read, and in between 1 GB per second from Southbridge to GPU here, and I/O also passing control bus here, and here IBU bus interface unit is unit interacts with memory controller 0, GDR3 64-bit, and also the other memory control and also memory controller 1, GDDR3 64-bit, and also interacts with I/O. GPU core 500 megahertz interacts with HSIO, and HSIO interacts with HSIO in EDRAM die, and below anti-aliasing Z alpha stencil with 192 processors, and it's connected to EDRAM 10 MB rendering memory inside the EDRAM die. You can see the Southbridge here. So it has PCI Express and XMA decoder and SMC. Southbridge interacts with DVD drive 12x 2-layer through SATA, and Southbridge interacts with 20 GB HDD through SATA. Southbridge interacts with front controllers through USB and other ways. And Southbridge interacts with memory units, and it can have it can go through USB, and Southbridge interacts with rear panel USB, wireless LAN, etc. through USB. Ethernet 100 MB. Southbridge interacts with Ethernet 100 Mbps. IR is connected to Southbridge, and Southbridge is can connect to audio out. Southbridge interact with flash. Southbridge interact with system control. As an example, we can consider Xbox 360e. The model Xbox 360e at Microsoft E3 press conference on June 10, 2013, another hardware revision of the Xbox 360 known as Xbox 360e was unveiled for immediate availability. It is a revision of the S model with a new Xbox One spared casing carrying a more rectangular appearance and a two-tone color scheme. It has one fewer USB fewer USB port and no SPDIF, UBPR component and or S-video connections. Its internal hardware is otherwise similar to the S model. SKUs and pricings for new model are identical to those of previous model. As an example too, we can consider this connect Xbox 360 game console to a wireless router function. Step 1, connect the appropriate wireless network adapter to the console. The Xbox 360 can also connect directly to your router with an Ethernet cable. Step 2, turn on your Xbox 360 and select the settings pane from the home page. Step 3, choose system. Step 4, select network settings. Steps 5, on the next screen, choose the name of your wireless network from the available options. Step 6, enter your network's password and select done or press the start button on your controller. Your Xbox 360 will access your network and test the connection. The final report will give not only your connection status but that of Xbox network and its services. Select continue to finish the setup. Here you can see step 4, select network settings. As an error example, we can consider system error, contact Xbox support, contact Xbox customer support, error code EXX. These errors mean that there may be a problem with the console. The EXX represent the following error codes: E07 through E20, E22 through E63, E69, E96 through E99. Now we are focusing on Windows Phone 7.5. Windows Phone 7.5 features a version of Internet Explorer Mobile with a rendering engine that is based on Internet Explorer 9. As of in Windows Phone 7.5, contacts can also be sorted into groups. Features subsequently implemented on Windows Phone 7.5: Internet sockets, cut, copy and paste, partial multitasking for third-party apps, connecting to Wi-Fi wireless access point with hidden SSID but without WPA, tethering to a computer, custom ringtones, universal email inbox, USSD messages, VoIP calling through a separate app. Here you can see a Windows 7.5 Mango. As an example, we can consider 7.10.8107 refresh. The version 7.10.8107 changes are LTE support, fix keyboard disappearing bug, fix location access issue, other bug fixes. As an example too, we can consider email configuration for Windows Phone 7.5. Here step 1, from your phone's start screen, locate settings, then skip to step 3. If setting is not pinned to your start screen, then flick left or click the arrow at the top right of the main screen to go to the applications list. Now, step 2, scroll down the list of applications until you find settings. Step 3, the settings screen will be displayed. Click on email accounts. Step 4, select add an account from the top of the list. Step 5, select other accounts. Pop an IMAP from the list. You may need to scroll down to see all the options. Step 6, in the email address field, enter your internode email address. For example, username at internet.on.net. In the password field, enter your internet password.click internet.password. Click sign in once you have entered your details. Windows Phone will attempt to auto-detect the settings for your internode email account. Step 7, you will be returned to the email and account screen. Your account will be named on by default. Click on to access the full settings for your email account. Step 8, the full account settings will appear. Double check your screen your settings. Change the account name to Internode. Confirm that your email address is correct. Specify how frequently you would like to phone to check new messages. Check your name field. This is how your name appears to others when they receive email from you. By default, Windows Phone 7 will automatically fill your name based on your Windows Live email address. If you would prefer another name or business name, please change this information. Click the tick at the bottom of screen once your settings are correct. You can see the screen for step 3. The settings screen will be displayed. Click on email and account. We can consider this error as an example. There has been a problem completing your request. Try again later. Error code D000F001. This occurred Windows Phone 7.5 or 7.8 HT0 RADA. Basically, while marketplace is not working. Now we are focusing on Converged OS Kernel. The Xbox 360 and Windows 7.5 began having a new look and feel that later got modified in Xbox One, inclusion of a dashboard and so on, and with Windows Phone 8 the look and feel was fully embedded. Now we are focusing on Xbox One. In November 2013, Microsoft released Xbox One, a more powerful system that addressed one of the most persistent flaws of the Xbox 360. A larger, better ventilized housing combined with more responsive cooling mechanisms meant that the Xbox One would not be subject to the overheating issues that had plagued the earlier console. Here you can see Microsoft Xbox One's architecture. The Xbox One architecture is very similar to AMD's Trinity and Carbine APUs in overarching system design. Microsoft did not just take what was and wire it to their controllers. There were some pretty massive changes to the Uncore and Southbridge that result a very unique device. Let's dig into the details. The Xbox One system layout including system on a chip, SoC, Southbridge, and peripherals. First iterations of most consoles tend to be multi-chip devices for cost reasons. The philosophy is to make two of the biggest chips that you can afford, then shrink them a few times to drop costs. Traditionally, these tend to be two approximately 300 plus square millimeter devices, which are then shrunk to two smaller devices then when the next process become affordable, which is then followed up to combining them into one SoC, smaller than two older ones combined on the next shrink if costs are amendable. Since the two biggest components of any system are CPU and GPU, that has meant one die for each. Southbridge Xbox One XBO is a bit different because it's based on a PC architecture, AMD's APU to be more specific. That means the CPU and GPU are both tightly coupled and on one die somewhat because of the functionality necessary in a modern system and partially because they can actually do it on one chip now. The main SoC is the overwhelming majority of functionality, while the second chip is effectively a design south bridge. These devices are usually pin bound and not very performance sensitive, so they are made on a 102 process. If you look at what functionalities contains, three USB 3 ports, two SATA ports, PCIe, some video IOs, and eMMC controller. There isn't really all that much to it. This chip mainly a boot ROM, flash host, and some lower speed IO controllers that handles different voltages in a more cost efficient manner than a high speed 28 nanometer SoC. Everything that really matters is on the main SoC. Here in on SoC, the 8 CPUs and more, 8 AMD Jaguar cores organized into 2 blocks of 4 each with a 2 MB 6-way L2 cache shared among all associated CPUs. As you might expect, the two L2s are coherent but not directly addressable by CPUs in the other group of 4. Each Jaguar core has 32K of 2-way L1 I at and 32K of 8-way L1 D as well. AMD's Jaguar only goes up to 4 cores, so Microsoft has to come up with the mechanism to both ensure coherently among the 2 clusters of 4 CPUs and the rest of the system, including the GPU. This is where a lot of what Microsoft added to the system came in. The most notable change here was the data path between CPUs, and the Northbridge system fabric were massively beefed up. These are for coherent memory. There are coherent memory access, non-coherent traffic, and all the major blocks are coherent with each other. If you think about the sheer volume of coherency data that needs to go between 2 CPU blocks, Microsoft probably had to beef up to L2 to NB links to much that of the L1 to L2 links. Don't discount this as a much minor change. It is both critical to the system performance and very complex thing to do. It will be interesting to see how Sony did their variant, if they ever give a talk on the PC4 architecture. Main memory speeds and coherency. The CPUs connect to 4 64-bit wide 2 GB DDR3 2133 channels for a grand total of 68 GB per second bandwidth. Do not count this do not do note that this number exactly matches the width of a single on-die memory block. One interesting thing to note is that the speed of the CPU MMU coherent link to DRAM controller is only 30 Gbps, something that strongly suggests that Microsoft stick with the Jaguar's half clock speed NB speed. And note that if the NB to DRAM controller is 256 bits per 32 bytes wide, that would mean it runs at about 938 megahertz, 1.88 gigahertz if it is 128 bits per 16 bytes wide. And you would be very surprised if it was 128 bit wide. Wires are cheap, power savings areas not. Why is this important? Unless Microsoft's Xbox One architects are masochists that enjoy doing needless and annoying work, they would not have reinvented the wheel and put the arbitrarily clockable and asynchronous interface between the NB and CPU cores per L2s. Added the complexity, lowered performance, and die penalty for absolutely no useful upside is not a good architectural design. That means the Xbox One's 8 Jaguar core scores are clocked at approximately 1.9 gigahertz, something that wasn't announced at Hot Chips. Another thing to notice is the rather odd direct and coherence path between AV in block in the GPU address accelerator area in the audio DMA unit in the I/O area. The audio DMA unit also has a direct link to audio out resize composing block. Both of these are one way. Since one is an inbound unit and the other is an outbound unit, that kind of makes sense. If there is need to go to the other way, the two can talk via the CPU MMU. While this may not make much sense on the surface, much of the XBO audio functionality is devoted to processing the kinetics data stream, so high bandwidth and low latency are kind of necessary. Here you can see main system on a chip SoC. SoC interacts with 8 GB DRAM. The main and AV out in main SoC is connected to HDMI SPDIF. It is connected to HDMI SPDIF out, and PCIe and main SoC is connected to gigabit Ethernet MAC and PHY. It's interacts with Ethernet. PCIe in main SoC is connected to PCIe in Southbridge, and basically here PCIe in main SoC interacts with PCIe in Southbridge. Um, you can see the south bridge here. IO clocks, system control. HDMI in is connected to HDMI, and HDMI is connected to HDMI in south bridge. USB in south USB in south bridge interacts with Wi-Fi. It may connect to game controller. Or interact with game controller. A USB in south bridge interacts with Wi-Fi here again. The third USB in south bridge interacts with Xbox One kinetics, and AV out in south bridge is connected to AV in main SoC. eMMC 4.5 interacts with 8 GB flash. SATA 2 interacts with 50 GB HD, and second SATA 2 another SATA 2 interacts with Blu-ray. As an example, we can consider Xbox One X. Microsoft first teased Xbox One X, a high-end hardware revision of Xbox One, at E3 2016 under the codename Project Scorpio, and released it on November 7, 2017 with a 1 TB model priced at $499 and a limited pre-order exclusive Project Scorpio edition with a dark gradient finish, vertical stand brace, and green Project Scorpio inscriptions on the console and bundle controller. As an example too, we can consider activate developer mod on your retail Xbox console. Step 1, start your Xbox console. Step 2, search for and install the Div Mod Activation app from the Xbox One store. Step 3, launch the app from the store page. Step 4, note the code displayed in the Div Mod Activation app. Step 5, register an app developer account in Partner Center. This is also the first step towards publishing your game. Step 6, sign in to Partner Center with your valid current Partner Center app developer account. If you don't see multiple options in the left-hand navigation pane, or don't see the create a new app option in the overview section, following steps and activation links will not work. Make sure you fully registered your app developer account from the previous app. Step 7, go to partner.microsoft.com/Xbox config/devices. Step 8, enter the activation code displayed in the Div Mod Activation app. You have a limited number of activations associated with your account. After developer mode has been activated, Partner Center will indicate you have used one of the activation associated with your account. Step 9. Click Agree and Activate. This will cause the page to reload and you will see your device populate in the table. Terms for Xbox Developer Mode Activation Program agreement can be found at Xbox One Developer Mode Activation Program. After you have entered your activation code, your console will display a progress screen for the activation progress. After activation has completed, open the Dev Mode Activation app and click Switch and restart to go to the developer mode. Note that this will take longer than usual. You can see the screen for the step 3. Launch the app from the store page here, and as an error example, you can consider system error E101. 00000503 8007 0079. Some Xbox One users are suddenly encountering the Xbox One system error E102 error during startup, during the installation of an OS update. This particular error code is signaling an underlying issue with the updating process. Now we are focusing on Windows 8. Windows 8 in 2012 offered a start screen with applications appearing as tiles on a grid and ability to synchronize settings, so users could log on to another Windows 8 machine and use their preferred settings. Here you can see Windows 8 architecture. Here you can see Windows 8 platforms and tools. Here you can see Metro Styles app and desktop apps. In view level, you can see under Metro Style apps XAML and HTML and CSS. In model controller, you can see XAML can interact with C, C++, C#, VB, and HTML and CSS. Under HTML and CSS, JavaScript and Chaka is here. In system services, WinRT API is here, and communication and data, graphics and media, devices and printing, and application model. In desktop apps, view, model controller, and system services level, HTML, JavaScript, and C, C++, and C#, VB, and system services level, below HTML and JavaScript, Internet Explorer is there, and below C and C++, Win32, and below C# and VB, .NET and SL, and kernel, Windows kernel services are here. As an example, we can consider Windows 8 Enterprise. So edition Windows 8 Enterprise. Windows 8 Enterprise provides all the features in Windows 8 Pro except the ability to install the Windows Media Center add-on, with additional features to assist with IT organization. This edition is available to software assurance customers as well as MSDN and TechNet professional subscribers, and was released on 16th August 2012. As an example 2, we can consider a settings screen in PC settings screen in Windows 8. To open to open the PC settings screen, press the Windows key, and at the same time press I key on your keyboard. This will open the Windows 8 settings charm bar. Now click on the change PC settings option in the bottom right hand corner of the charm bar, and this will open the PC settings screen, which contains numerous settings categories that you can use to configure Windows 8. As an error example, we can consider inaccessible boot device. To fix the blue screen error with the name inaccessible_boot_ device, try any of the following fixes explained below, listed below. Fix number 1, run the check disk command. Fix number 2, reconfigure BZD. Fix number 3, check for faulty RAM module low hardware. Now we are focusing on Windows Phone 8. Windows Phone 8 is the second generation of the Windows Phone mobile operating system from Microsoft. It was released on October 29, 2012, and like its predecessor, it features a flat user interface based on the Metro design language. It was succeeded by Windows Phone 8.1, which was unveiled on April 2nd, 2014. Here you can see a Windows Phone architecture. As of most mobile operating system, Windows Phone has a pretty layered architecture. The kernel and OS layers are mainly provided and supported by Microsoft, but some layers are provided by Microsoft partners depending on hardware properties. These layers are provided in the form of a board support package (BSP), which usually consists of set of drivers and support libraries, ensure low-level hardware interaction and boot process created by the CPU supplier. Additionally, it comes through original equipment manufacturers, OEMs, and independent hardware vendors, IHVs, that write the required drivers to support the phone hardware and specific components. Here SV refers to SoC vendors. The above the lowest level hardware level comes the layer responsible for boot process. After phone system, after the phone's system on chip SoC, bootloaders initialize all the hardware components. They boot the unified extensible firmware interface UEFI and hand over the control to the UEFI applications written by OEMs, SoC vendors, and Microsoft itself to use UEFI drivers and services. At this point, to deal with all requirement of the Windows Phone boot modes, normal, update, restore, and flash, UEI environment launch the boot manager, which determines the boot mode. To facilitate interaction between hardware and the rest of the operating system, Microsoft provide a hardware abstraction layer (HAL), which offers routines that can be used to abstract the low-level hardware details from drivers and the OS. If the HL needs any extension, the SoC vendors add their own HLs as HL extensions. The Windows core includes kernel mod drivers framework KMDF. This framework is responsible for the Windows kernel mod IO manager, which manages communication between applications and the interfaces provided by device drivers, file system, and storage. It is also responsible for kernel mod memory manager, which manages physical memory, random access memory by handling allocation, deallocation of memory virtually and dynamically, and by supporting memory mapped file, shared memory, and copy on write. The KMDF also provides support for human interface device HID, class drivers, and kernel mod security reference monitor that makes sure that any action taking place on the OS is not violating system policy. The KM security reference monitor provides routines to work with access control list ACL. Windows Core also provide low-level network components. All the kernel mod drivers are provided by Microsoft. Another stack is provided by respective SoC vendors added to Windows Core, that is Power Management Engine plugin PAP extensions, which are third-party extensions to the Windows Power Management architecture. The PAP communicates with the lower management integrated circuit through some bus to manage power rails and clock resources. The mobile core has the user mod drivers framework UMDF, which abstracts hardware functionalities and runs in the user mod environment. This stack is provided exclusively by Microsoft and includes core CLR, shell services, media foundation APIs, audio and video rendering stacks that offer the possibility to access and synchronize media files on the device, and DirectX 11 graphics layer, direct write APIs, Windows imaging component APIs, so on, and direct 2D APIs. The mobile core also includes the extensible storage engine ESENT that allows applications to store and retrieve data via index and sequential access, which is optimized for applications that need high performance and low overhead storage storage of structured and semi-structured data. The The latest stack in this big layer is the radio telephony stack, which is an asset to APIs that help in the development of communication applications for Microsoft Windows Phone. At the top of the kernel resides the main operating system within the application platform layer. This is the sub-layer stack made principally of the Windows Phone shell system, phone shell system, application connection management, and platform services. Here, package manager, it handles the application's life cycle. It's responsible for installation and installation and for maintaining the application metadata. Execution manager, this is responsible for creating the hosting process of application and control the logical aspect of the application's execution lifetime and background agents. Navigation server, it manages all the movement between foreground application on the phone. The navigation server works with the execution manager to orchestrate with which applications to start or which applications to reactivate. Resource manager, it is responsible for monitoring the system resources, CPU and memory usage by enforcing constraint on the active process. In this diagram, you can see in blue the ownership is from Microsoft, and OEM ownership is in this color, and SOC is in this color, and Microsoft OEM and SOC is in this color. On top you can see application platforms by Microsoft, and below that you can see user mode drivers, UMDF, and shell services, user mode drivers, UMDF, shell services, Microsoft Foundation, audio stack, video rendering stack, DirectX 11 user mode graphics stack, Essence database, and radio telephony. Below that you can see kernel. In that you can within that you can see file system storage, IO manager, security, network manager, networking, and PAP extensions. You can see kernel mode drivers, KMDF here, and below that you can see HL extensions. Below that you can see HL, and below kernel you can see boot manager and UEFI apps. Below that you can see UEFI, and below that you can below HL and UEFI you can see hardware. As an example, we can consider version 8.0.102.11.004. that's called GDR1, General Distribution Release 1. A minor update known as Portico was rolled out in December 2012 that brought some improvements and bug fixes, including enhancement in messaging, more efficient Bluetooth connectivity, and always on setting for Wi-Fi connections, among other additional platform updates. As an example 2, we can consider configuring Microsoft Windows Phone 8 using Exchange Active Sync. Step 1, launch the mail application from the home screen. Step 2, if it is the first time, create a new account. Otherwise, choose add email account from the menu options. Step 3, select advanced setup. Step 4, enter your email address and password and click next. Step 5, select Exchange Active Sync as the account type. Step 6, enter the name of your domain. For example, feelmorelaw.com, and the server address, for example, mail.feelmorelaw.com. Step 7, click sign in. Here you can see the screen for step 5. Select Exchange Active Sync as account type. As an error example, we can consider this error code 801881CD. This error appears when you don't have enough storage space on your phone to install the update. Now we are considering focusing on Converged App Model. There was a big difference underneath that led the users and developers to Windows 8.1 for mobile and desktops. This created the Converged App Model and resulted in the possibility of development of universal apps. Now we are focusing on Windows 8.1. Windows 8.1 is a release of the Windows NT operating system developed by Microsoft. It was released to manufacturing on August 27, 2013 and broadly released for retail sale on October 17, 2013, about a year after the retail release of its predecessor, and succeeded by Windows 10 on July 29, 2015. Windows 8.1 was made available for download via MSDN and TechNet, and available as a free upgrade for retail copies of Windows 8 and Windows RT users via the Windows Store. A server counterpart was released on October 18, 2013, entitled Windows Server 2012 R2. Microsoft ended mainstream support for Windows 8.1 on January 9, 2018, and extended support will end on January 10, 2023. Here you can see a default Windows 8.1 start screen. As an example, we can consider Windows 8.1 Enterprise. Windows 8.1 Enterprise is the version that brings business premium features to Windows. Available through Windows Software Assurance, Windows 8.1 Enterprise includes all the same features of Windows 8.1 Pro, and then adds things like Windows to Go, Direct Access, Branch Cache, App Locker, Virtual Desktop Infrastructure (VDI), and Windows 8 App Deployment. As an example too, we can consider how to access settings in Windows 8.1. You can access the settings in Windows 8.1 by clicking the Settings button within the charm bar. As an example, you can see here some commonly seen error codes in Windows Update errors in Windows 8.1 and 7. A common cause of errors is inadequate drive space. Now we are focusing on Windows Phone 8.1. Windows Phone 8.1 is the third generation Microsoft Windows Phone mobile operating system, succeeding Windows Phone 8. Rollout at Microsoft Build Conference in San Francisco, California on April 2nd, 2014. It was released in final form to Windows Phone developers on April 14th, 2014, and reached general availability on August 4th, 2014. All Windows phones running Windows Phone 8 can be upgraded to Windows Phone 8.1 with release dependent on carrier rollout dates. Here you can see Microsoft iTunes update on December 2014 and new Windows Phone 8.1 capabilities. New in Windows Phone 8.1 enterprise application restrictions. Enterprise assign access configuration service provider, login support for enterprise server creation, policy manager configuration for server provider, remote lock configuration server provider, remote ring configuration server provider, VPN configuration server provider, VPN and web authentication broker support for enrollment process, and Wi-Fi configuration server provider. Updated in Windows 8.1 with iTunes in Intune. Certificate configuration service provider, discovery web service, DM client configuration server provider, enterprise application install, update and uninstall. In this diagram you can see OS capabilities is here, and below next to that CSPs are here, and CSPs are connected to enrollment and DM client and app deploy, and then HTTPS here, and enrollment client is connected to enrollment server through HTTPS and web service, and DM client is connected to proxy through syncml, and app deploy is connected to app content through web service here, and you can see here enterprise management server. As an example, we can consider version 8.10.15116.125 GDR2. Information regarding GDR2, also referred to as Update 2, was released in February 2015. It was revealed that Microsoft was working on a second update for Windows Phone 8.1 that would provide increased security for OEMs, add extra languages and additional technology support, and is also reported to bring an anti-theft mode. As an example too, we can consider this: completely block the Windows Phone store in environment Microsoft Intune standalone. This can be achieved by creating and deploying a Windows Phone configuration policy, Windows Phone 8.1. In the application section, enable the allow application store Windows Phone 8.1 plus setting and configuration it to no. As an example, we can consider error code 80070057 from store in Windows Phone 8.1 update in environment Nokia Lumia 530 model with Windows Phone 8.1 update, and OS version is 8.10.14234.375. Now we are focusing on Windows on devices. Windows for IoT is a member of the Windows product family that brings enterprise class power and power security and manageability to the Internet of Things. It leverages Windows embedded experience, ecosystem, and cloud connectivity, allowing organizations to create their Internet of Things with secure devices that can be quickly provisioned, easily managed, and seamlessly connected to an overall cloud strategy. Here you can see Windows 10 unified distribution channel and device families. Conceptually, this is really no difference than what was offered 3 years ago when Windows 8 launched with the Windows runtime. Windows 10 adds this mix by allowing application built using this platform to run on all Windows devices moving forward. Hence, the universal Windows platform. The Windows part of the name comes from the fact that once an app is built to target this platform, it will work on all Windows devices with that platform deployed on it. This figure illustrates the device families and services that are exposed by the UWP. You will be hard pressed to find a platform that can deliver this kind of end-to-end solution to developers targeting it. If you take the other two competing platforms, iOS and Android, you will find that neither provide the broad reach UWP app does. Sure, you can build an iOS app for iPhone and iPad, but such an app does not target a broader OS X workstation. The Android world is less consistent even within the mobility device family and offers no true workstation experience. Here you can see in UWP apps the device families, devices plus IoT, mobile, PC, Xbox, Surface Hub. Here you can see the services that are exposed by the UWP, adaptive and here adaptive user interface, natural user inputs, one SDK plus tooling, one store plus one dev center, and here you can see devices plus IoT. As an example, we can consider this edition, Windows IoT Enterprise. Windows IoT Enterprise is a full version of Windows Enterprise with specialized features to create dedicated devices locked down to a specific set of applications and peripherals. As an example too, we can consider this C# code. Here we will connect an SPI accelerometer to your Raspberry Pi 2 or 3 OptiSquad or Dragon Board for 410C and create a simple app to read data from it. Here this code segment is initialize SPI bus in SPI accelerometer. Here you can see the here are the connections shown in on a breadboard for Raspberry Pi 2 or 3 here. Here to use the accelerometer, we need to initialize the SPI bus first. Here is the C# code for that. Here is the overview of what's happening, and first we create an SPI connection settings object and set the clock speed and clock polarity and chip select line. Next we get selector strings from for all SPI controls on the device. And use that to find all SPI bus controller in the system. Finally, we create a new SPI device from the first SPI control on the system, DIS0, and check that it's available for use here. As example 3, we can consider setting up your Intel Galileo V2 board. First insert a micro SD card into your PC and format it with FAT32. Then download the following 3 files from MS Connect site. You will need to be registered and log in to download these files. Apply -brutemedia.cmd imaging script for Windows Image, Microsoft Windows Image WIM for embedded devices, the MSI controller optional but recommended, install templates and an application that helps perform certain tasks with your Galileo. Navigate to the directory where you downloaded the files and run the following at administrative command prompt. This is the command apply /bootmedia.cmd destination, and whatever your SD card drivers, letter IS -image, latest WIM image, and hostname Galileo -space -password, and here admin. This is the output for the sample output for the last step for the command apply -bootmedia.cmd and the rest. As an error example, we can consider this error in Windows IoT, Raspberry Pi 2 in C#, unable to load DLL, mydll.dll. The specified module could not be found, exception from hresult 0x800707E. Now we are focusing on Windows 10. Now with Windows 10, we not only have the kernel in common, but also all the fundamental pieces of the OS. Also, the applications that were universal apps had two separate binaries, whereas now the Windows core has one single binary across platforms. The UAP is a collection of contracts and versions. This is the new platform on which the developers will be writing their applications. UAP is built on the Windows core, that is a collection of low-level APIs that are arranged in the form of contracts. Contracts are a kind of assurance given by Microsoft to app developers, stating that they can now start build against the UAP. Microsoft will ensure that no matter what Windows app platform and device users are on, they will be able to run it, and Microsoft will ensure that the app runs smoothly on previous compatible versions as well. This essentially means that developers will no longer write the application targeting Windows. Rather, they will write it against UAP, and Microsoft will guarantee that the application will run on all platforms. Here, you can see Windows 10 app API landscape. Windows 10 apps can be built using HTML, JavaScript, .NET languages, C# and VB, or native C and C or C and C++ through an extension of C, C++ called C++ /CX. Regardless of the technology used to develop the application, the Windows team has done a good job of providing a core set of APIs that are projected into each of the targeted languages. Here you can see the Windows 10 UWP, Universal Windows Platform interface here. For all UWP developers, regardless of technology or language used, applications built using these projected APIs end up in a package containing an application code in binary or text format, resources, libraries, and a manifest that describe the app, names, logos, and so on, its capabilities such as areas of the system or specified device like cameras, and everything else that's needed to make the app work, such as file associations, declaration of background tasks, and so forth. The manifest describes the application to Windows Store and also potential Windows clients that download it from the store. The manifest is the crucial component of the development story for Windows 10. The exact workings of the app manifest as it relates to publishing your application and setting up its permissions are discussed in the section entitled Developing for Windows 10 UWP Apps. Here you can see Windows 10 app APIs. Below that you can see XAML, and below that C and C++, C#, VB, and here you can see HTML, CSS. Below that JavaScript, Chakra, and below these languages you can see UWP APIs these communication and data, graphics and media, devices and printing. And you can see the application model here also under WP APIs, and below that you can see Windows Core OS services. As an example, you can consider this baseline edition Pro for workstations. Pro for workstations, Windows 10 Pro for workstation is designed for high-end hardware for intensive computing tasks and supports Intel, Xeon, AMD, Opteron and latest AMD EPIC processors, up to 4 CPUs, up to 6 TB RAM. The REFS file system, non-volatile dual inline memory module, NVDIMM, and remote direct memory access RDMA. As an example too, we can consider this target platform and Microsoft.Universal here. Developers who get tired of testing their application for the ever-evolving build of Windows can now safely rely on the UAP that ensures that no matter what they target and whichever version they target, they will have the application running. So developers don't need to worry about the specific Windows to test on. As an example 3, we can consider how to open msconfig in Windows 10. Step 1, from the taskbar, search system configuration, and step 2, select the top result, system configuration desktop app. As an example, we can consider this error code 0x80070652. According to Microsoft, this type of errors occur when Windows 10 initiates an automatic update and a program requires user interaction. This is end of my presentation. Thank you for watching it.